Okay, now let's look at this. You have an equation here, and then you have a condition for the unknown value. It must be less than 0. Now, so what you have to do, you have an equation. Okay, you have a x to the power 2, so basically it's a quadratic equation. So if this is the case, let's move the 48 to the left side, or the equal sign. In order to find the value of x, let's factorize it. So x minus this 48, 48, so is basically minus 12, and x plus 4. Okay, now therefore you have two answers. One is 13, or the other one is x equal to minus 4. Okay, now let's look at the condition set for x. You say that x must be less than 0. If it's less than 0, then the answer must be this. Okay, the x value that is required is the negative x value, which is minus 4. But then they are not asking for the value of of x, the negative value of x. They are asking for the value of this mathematical expression. So x plus 10, taking the negative x value based on this condition, which is minus 4 plus 10, then you give you 6. So the answer is C. Okay. Okay. Now. Okay, now this question here, it's a rocket, it's a water bottle rocket. Now, what it's saying is, this is the path, okay? That means this is the starting point where you shoot off from. Okay, let's look at the first simulation of is a rocket without a parachute launched from the roof of the gymnasium. So this at this point here, okay, the height of the rocket is actually the height of the gymnasium. Okay, so let's remember this height of the gymnasium, and that is also the starting point of the rocket. Okay, now the scatter plot show the approximate path of the rocket. I mean, with 1 second, I mean after, let's say this 1 second, then it's about this in meter. So this 1 meter, 2 meter, 3 meter. Okay, so this 3 meter, roughly 3 meters, slightly less than 3 meter. So after 1 second, the height of the rocket, the vertical height of the rocket from the ground, okay, will be roughly 1, 2, 3, 4, 5, 6, about 6.3 meter. Okay, so that's how you interpret it. Remember, this height is from the ground. Okay, why? Because you have taken into consideration of the height of the building, the gymnasium buildings. Okay, so this is the starting point. So by the time 1 second later, it already at 6.3 meter from the ground. At 0 second, at the starting, is roughly slightly less than 3 meter from the ground, which is the top of the roof of the building. Okay. Now, so by plotting the point, the software will be able to generate this equation, which determine the height, the vertical height of the rocket. Now, what the question asks is, what does h represent? Okay. When h is the height in meters of the rocket, t seconds after it was launched. Okay. Now, what does the number 14 most likely represent in this equation? Okay. So what did this represent? Okay. Now, h is equal to minus 4.9 t squared. It is 39.2 t plus 14. Okay. The question asks, what is this 14 represent? Now, as I said before, this is always the y-intercept. Okay, y-intercept is when you talk about y, this function, when you look at this function, the quadratic function, this is the y-intercept. Okay, y-intercept means when x becomes 0, then whatever value you obtain from y will be the y-intercept. So when x becomes 0, our normal graph, where the graph cross the y-axis, when x goes to 0, basically the y-axis is actually equal to x equal to 0. Okay, so when you make x 0, when x becomes 0, so in this equation y becomes c, and y is the point where the graph intersects with the y-axis. That is this point here. So this is the y-intercept, and x equals to 0. Okay, now you look at this question now. If I make t equal to 0, t equal to 0, what do you get? You get 0 plus 0 plus 14. Okay, when t equals 0, based on this graph here, it's actually basically at this point. Okay, when t equals to 0. So at this point, what is your height? Your height is roughly 3. Okay. So it's not given the scale, but in this case, if this is 14, then basically teacher make a mistake. Basically the scale would be 1 boxes is 5 cm. Okay, so here you look at the dot, it's slightly below the third boxes. The third boxes is 15 meter. Okay, so this point here is where the graph will intersect with the vertical axis, and you know this is the y-intercept. Okay, but just now at the beginning of the discussion of this question, you notice that this is the point where the rocket should form the roof of the building. Okay, so in other words, h equal to 14 is actually the height of the building, the gymnasium building. Okay, so let's look at the answer and pick the correct one. let's look at it. So the height of the gymnasium from which the rocket was launched. So this would be the answer. Okay. Now, so this is your y-axis, x-axis. Now, line is shown in a graph could be the graph of which equation? Oh, this is below the x-axis, so this should be y equal to a negative value. So look at this equation over here and see which one end up. Remember, this is a horizontal line. Okay, so this, the equation of this would be y equal to where this point where it passes through, which is negative. So the equation should be y equal to negative. Now, if you look at this, you make y the subject, it become minus x minus 2. Okay, so this is, if you have an x term, then it is a slanting line. Why? Because there is a gradient. Okay, this is a minus 1 gradient, which is slant this manner, which is not this. So this cannot be the answer. Okay, similarly, y equal to minus x. This is also a slanting line. The gradient is minus 1. If you plot this, y and x, so is this. Okay, now what about this? This y equal to, if you cancel off the x before you move the minus 2 here, you cancel off the x, so y become 2. Y become 2 basically is a line that is running parallel with the x-axis, a horizontal line, and it passes through 2 on the y-axis. But this is below the x-axis, it has to be a negative value. So this is not the answer. Okay. Now let's look at this. If you cancel this off, then when you bring the 2 over to there, it becomes minus 2. Okay, so y equal to minus 2 is this. So this will be the answer. Okay. Okay, now let's look at the next question. It says that if x and y is a solution to the system of the equation above, what is the value of y squared? So to find the solution to these two equations, you have to do simultaneous equation methodology. Okay, so once you do that, you can find the x and y value. Then you can find the square of the y value. So how would you do this simultaneous? Okay, you can make x the subject, or you by using substitution, or you can make this x become 2x, then use the process of elimination. Okay, now let's consider this equation 1, this equation 2. Okay, now this equation 2, I want to make this become 2x. So I take equation 2 and I multiply by 2. So 2 times x become 2x. Okay, 2 times 3y becomes 6y. 2 times 3 becomes 6. Let's put equation 1 here side by side. 2x plus 5y equal to 8. Okay, now, so this is still equation 1. I didn't make any change to it. Then this I have made a change by multiplying a 2. So it become, you cannot call it equation 2 anymore, you call it equation 3. Now taking equation 3 minus equation 1, 2x minus x, you got 0 here. 6y minus 5y, you got a y. 6 minus 8, you got a minus 2. Okay, now you're asking for the value of y2. So y2 will be, y squared will be equal to minus 2 times minus 2, which gives you 4. Okay, so the answer is this.